Good afternoon and welcome. Please take your seats. Welcome to the session on the open process automation status. My name is Harry Forbes. I'm from ARC Advisory Group. We've got some outstanding presentations this afternoon. First of a kind in the world. I'd like to give you just a little bit of overview of what this session will consist of. I'm going to speak very briefly at the beginning because I'm not the star here. And then following me, we have Abdullah Al Khalifa from Saudi Aramco, who will discuss the Saudi Aramco work in open process automation. We were hoping to have them last year, but they could not come, but this year, kindly, they are here. So Abdullah Al Khalifa will be the first speaker. The second speaker will be Dave DeBerry from ExxonMobil, and he will discuss the status of the ExxonMobil Lockheed Martin proof of concept program. And our third speaker will be Michael Kraus, assisted by Don Bartusiak. Michael is from BASF, Ludwigshafen, but he is representing Namur, and Don is representing OPA or ExxonMobil or whoever, one of his many hats. So without further ado, let me dive in here. Given the level of interest and importance of the presentations that are to follow, I realize that you are not here to listen to me. Nevertheless, I'm going to take just a couple of minutes to explain some of the reasons that personally I'm more optimistic about the prospects for open process automation than I was a year or two ago. Recently, I had a discussion with a high-level executive from an automation business who was very pessimistic about the prospects for open process automation. And the reason he gave is on this slide. He said, our customers do not want to manage or live in a plant where they have to manage their application software across hundreds or thousands of devices. What he meant, I think, was that it was difficult enough to manage their automation application software across a smaller number of controllers made by one or two vendors. Managing applications for a unit or plant that would involve hundreds or even thousands of hardware modules from many different vendors with software from different suppliers would require an entirely new form of technology. It would have to be far better at managing these tasks than the software that customers deal with in real plants today. And yet, we find not only our industry, but other industries are busily creating architectures for doing exactly that, for distributed automation functions that are very similar. For instance, in the automotive industry, it's in the midst of developing a reference architecture that will encompass both car features for safety and convenience as well as autonomy. Part of that work is the definition of a standard set of operating system software and capabilities that's known as automotive-grade Linux. In telecommunications, a massive industry as well, companies are wrestling with virtualizing the functions that now take place in dedicated appliances at the base of cell towers. This is what they call NFV, or Network Function Virtualization, in their jargon. And they're even researching architectures for replacing their central switches by virtualizing them. Finally, the changes that we see addressing the industrial Internet of Things requires management of remotely deployed software at a large scale and over a long period of time. As one industry analyst said, this will require breakthroughs, not incremental improvements, but breakthroughs in the way that we develop and deploy software on all kinds of embedded devices. Knowing this, I have developed a 5-year forecast of what the world of automation software development, this is software development, will look like in the year 2023 and beyond, and I've condensed that forecast into one slide, so here it is. My forecast is that in 5 years, we will be living in a world of cloud development software. If software is eating the world, the software that is eating software development is coming from the cloud. Even in the insular specialized world of embedded system development, we are likely to be overtaken and swallowed by technologies that are now being developed and will be developed for managing cloud software. Now, please note, I am not saying that all applications will run in the cloud, not at all. I am saying that the software development and deployment techniques that we use for the cloud will overtake and dominate every other form of software development in the long run. Why? Let me give you two reasons. First, because the cloud is relatively new and, if you will, immature industry, although it is huge. Total spending on cloud computing is roughly estimated at $250 billion a year. That's billion with a B, and growing in double-digit rates. Yet the software technologies, which are now hot in cloud computing, did not even exist in public 5 or 10 years ago. Open source cloud software such as OpenStack, Cloud Foundry, Docker, Kubernetes have all been developed and publicized and open sourced in the last 5+ years. And experts on cloud computing agree that the current cloud computing stack has a lot of redundancy and can be dramatically improved still. So it's reasonable to expect rapid development in this area. Okay, but that's the cloud. Why does it matter to us in the automation space and in the embedded system space? The answer to that question is my second reason, is that these technologies are able to scale down to smaller systems, and this has been demonstrated already. Any number of edge computing products in the industrial space that you can see today already incorporate cloud technology such as Docker. Indeed, cloud technologies have been ported to even smaller systems, to the kind of low bill of materials systems that we might use for a single measurement. And not only that, but developers of cloud software are actively pursuing ways to make their software technology both smaller and more secure. Historically, we have known several different classes of software development, which had some overlap, certainly, but each required a unique form of development and tooling. My thesis is that over the next 5 years or so, one of these forms will come to dominate, and all these forms of development will more or less converge. Furthermore, this convergence will take place at a pace that is driven by open source technologies, not the much more slow, languid pace of development that we have become accustomed to in our industry. The pace of software technology innovation and the pace of penetration into other areas is going to be rapid. The first phase of this convergence will be the development of so-called cloud-native software, marking the convergence of conventional enterprise and cloud. The development and orchestration tools that are used for this will become commonplace and well-known, and this will drive the second phase of convergence as cloud-native software scales down to address the requirements of embedded systems. As I said, we see this already in the way applications are deployed in Docker containers in many industrial products that have been introduced in the last 2 years or so. And an emerging cloud technology still in research called unikernels brings some of the small footprint disciplines exactly of embedded computing into the cloud. And while this is presently an area of research, I do not expect it to stay that way for long. Again, this is a $250 billion business with lots of R&D money that's growing rapidly and dominated by huge software firms such as Amazon, Microsoft, and their ilk. These firms are fiercely competing for a huge and growing business, and it seems reasonable to expect that they will innovate rapidly. So what are the conclusions from my extensive research? Simply this: the convergence of all these forms of software development will be of major importance for all types of industrial automation businesses. As state-of-the-art cloud and DevOps development technologies penetrate into embedded systems, into new automation customers, we will see and learn the value of entirely new and vastly improved ways of developing, testing, deploying, orchestrating, monitoring, and maintaining and upgrading our software. If open process automation is to succeed, we will need to see massive improvements in these abilities. My thesis is that the tools developed for the cloud will become usable for almost all types of software development and deployment. And once these tools are applied effectively to areas of industrial automation, end users will have entirely different and much higher expectations from their automation system software. Management at scale and management over a long life cycle are requirements shared by all types of software: cloud, enterprise, industrial IoT, and open process automation. My advice is keep your eye on the cloud, because it's not just up there and it's not going to stay up there. It's coming down to where we live and where we work and manufacture. Thank you. Now,